So
and attacked me.
the other day, we looked at like terms and just combining like terms. Today we're going to be doing more of that, but we're going to see what happens in algebra if we start adding some brackets.
Don't do it. Nothing happens.
And a lot of times nothing happens, but sometimes it changes things. So in this one, our first example, we've got a 6x squared plus 5x minus 4 in one set of brackets, and we're going to add to that a 2x squared minus 10x plus 3. If we go to our grocery bag thing, you can think of the brackets as separate bags. In one bag, you've got a 6x squared plus a 5x minus a 4. And in our other grocery bag, we have 2x squared minus 10x plus 3. If you put both of those bags together, what would you have? So if we think back to our algetiles, which the x squareds were big boxes, so we would have in our first bag 6 of these big boxes. Would we shade them in or would we leave them open like that? Shade it in because it's a positive 6. 5x would show up as 5 of these bars. They would be shaded in too. And 4 would be 4 little ones. That would be what is in our first set of brackets. And in our second set of brackets, we've got 2x squareds shaded in, minus 10 x's,
Are you actually in dollars?
plus 3. And if you put both of those together, what would you have? How many x squares do we have?
8.
We'd have 8x squares.
Do we actually have to draw all this?
No, if you can do this in your head, that's going to be way better for you because drawing it out gets kind of annoying, especially when you deal with big numbers. We have 8x squareds. We can put those together because the 6x squared and the 2x squared are like terms. How many x's are we going to have? The plus 5 and the minus 10. Now, every time you have a positive and a negative one, they're going to cancel each other out. What are we left with? And I didn't quite draw enough, did I? 1, 2, 3, 4. I should have had one more long bar. We're left with negative 5x's. And how many ones do we have? Again, every time you have a positive, it cancels out with a negative. What are we left with? Negative 1. And I'll underline those ones in black. I'll give you another example right under this. And in that example that I put underneath it, you won't be able to do algetiles because I've got some y's in there and b's in there. Unless you want to make up a new shape for y and a new shape for b, then you could. See if you can do that one without your algetiles.
I would look it up, but you know.
Are there any like terms with 3x squared?
4x.
And if you put them together, you would get 7x squareds. Are there any like terms with the 5y? Minus 7y. If you put them together, you would get negative 2y. And finally, we have 1b here and minus 8b's there. If you put them together, you'll get negative 7b's.
Negative?
Because you had 1 and you subtracted 8, which would give you negative 7. Now, what we notice with adding is those brackets really didn't matter. It was the same. We did exactly the same thing as we did the other day when we didn't have brackets. And that's going to be true for adding. But when we subtract, it does matter. So here is our second example, and now there's a subtraction sign between our two sets of brackets. And so what we have is we have one grocery bag, and in our first grocery bag, and while you write it down, I'll draw this out. We have 7 of the x squareds. They would be all shaded in. We have minus 4 x's. Those ones would not be shaded in. And we have a plus 1, which would look like this. That's what's in our first grocery bag. In our second grocery bag, we have 5x squareds plus 5x's and minus 2. And what this means now is we have whatever is in our first grocery bag, we have to subtract or take out of it the second set. So what's going to happen when we subtract? Well, 7 subtract 5 would be what we'd have to do with our x squareds. Minus 4 subtract positive 5 would be what we have to do with our x's. And plus 1 subtract a negative 2 is what we'd have to do with our numbers. So what ends up happening is when we subtract, we change all the signs in the second polynomial. And we have a definition for this when we change all the signs. We call this the additive inverse. So we can take away our brackets. In the first one, we just are left with 7x squared minus 4x plus 1. But when we're subtracting, we can change all of the signs of our second one, because we're going to subtract 5x squared. We're going to subtract a positive 5x, which is the same as minus 5x. And we're going to subtract a negative 2. So this negative sign will go to this one, and to this one. Can you see when we had our positive sign, if we put the positive sign to each one, it doesn't change anything. But a negative sign always changes things. And so now we get 7x squared minus 4x plus 1 minus 5x squared minus 5x plus 2. And we have to look. Do we have any like terms? Is there any like terms with the 7x squared? There's a 5x squared. So if we put those together, what are we going to get? 2x squareds. Are there any like terms with the minus 4x? Minus 5x. If you put those together, what do you get? Minus 9x. Think of your number line. You're starting at minus 4, and you're going back 5. And finally, we have our 1 and our 2. If we put those together, we get plus 3. So if we have brackets and we are subtracting in front of the brackets, that subtracting sign goes to each one. You've got to subtract the 5, subtract this 5, and subtract that negative 2. And what's going to happen is you're going to change all of the signs in that second polynomial to figure it out.
What happens if they're... Can you go back for a second?
I can go back for a second. So again, here we're subtracting, and because we have a negative outside of our second set of brackets, that negative is going to affect everything inside that brackets. So you're going to get 4a plus 5c minus 3c minus a negative plus 3b minus c plus 4a. So notice how everything in that second polynomial, in the second set of brackets, how the signs all changed. Then do we have any like terms here? Anything that goes with the 4a? The other 4a. So if you put those together, you would get 8a. What about 5c? 3c. Anything else? And a minus c. So if you have 5c and you minus 3c and you minus another c, close. What's 5 minus 3? 2. And then minus another one? Yeah, if this was a plus sign, that would have been right. And do we have anything like terms with the 3b? No. So we still have plus 3b. And since what our answer right now has no like terms, we would be done. We've simplified it completely. We put all of our like terms together, and we have our answer.
No. I don't. Okay. Yeah. Thank you. You're welcome.
All right, let's see how you did. Now, when you're doing these questions, whenever you have that minus sign, it's a good thing to help yourself remember to draw these arrows to say that that minus sign goes to each one, to take the time to rewrite it without the brackets, where you change all the signs in the second polynomial if you're subtracting. And then if you have different colors or something to indicate which are your like terms, so you notice how I've been underlining them. Is there anything that's a like term with 3m squared? The negative 4m squared. What about the 5m?
3m.
And the 3m. Are those like terms with it as well?
Yes.
No. In order for it to be like terms, it has to have the same variable with the same exponents. So these two, there would have to be, if there was a little 2 here, then we'd underline this one as well. But since that 2 doesn't stick, it goes away, it can't be with that. So these two are the same. We can put those together, and we get negative m squared, because 3 minus 4. The minus 5 and the plus 3 are like terms. You can write a 1 here if you want, but if you just write a negative, it means the same thing. And if we have a minus 5m plus 3m, start at minus 5 and add 3, you'd get to negative 2. Any like terms with the 8n? Minus 5n. And 8n's minus 5n's leaves you with 3n's. So there's our final answer.
Can we stop doing this? Because this is really boring.
So on the last ones, we were dealing with expressions and simplifying them. Now we have an equation because there's an equal sign here. You have to figure out what number would go in each of these question marks in order to get this side equal to the other side. Do we have any like terms here? What do we have that are like terms with the 4x squared? This one here, that's a question mark? Yeah. And those two together have to equal that one. So with these underlined ones, if these two underlined ones on the left side have to equal this underlined one on the right side?
3.
It's going to have to be a 3, positive or negative?
Negative.
Yes. Because 4 minus 3 is going to give us 1. If we look at our next like terms, we've got a minus 3x something, and it has to equal negative 9x.
6.
6, positive or negative?
I'm not really sure about that.
Negative, because you have minus 3 minus 6 more will get you to negative 9. And finally, we have a 2 here, a number all by itself there. It has to equal 8. And it would have to be positive 6. Now this is the same kind of question that we were dealing with from before, but this one has some words. Instead of just having something minus something, this one says subtract this from this. So if I put this into a mathematical expression, which one goes in the first set of brackets? Which one goes in the second set of brackets? Because we want to subtract 3x squared minus 5x plus 2 from 8x squared minus 9x minus 8. The 8x squared minus 9x minus 8 would go first. You're correct. Because you're subtracting this amount from that. So the first thing we're going to do is we're going to write out what the question is saying. Now we have a minus sign. What do we do with a minus sign when we're subtracting? We've got to change all of these signs. That minus goes to each one. So now we can rewrite it. Minus a 5 will be plus 5. Minus a 2. Now that we've done that, are there any like terms with the 8x squared?
What?
Are there any like terms with the 8x squared?
Yeah, 3x squared.
The minus 3x squared. What would we get if we put those together?
5.
5x squareds. Any like terms with the 9x?
5x.
Negative 9x plus 5x gets us?
4x.
Close?
Negative 4x.
Negative 4x. And finally, the minus 8 and minus 2?
Minus 6.
Close. Think of your number line. You're at minus 8 and you go back 2 more.
Minus 10.
Minus 10. Excellent.